What's up, guys? In this video, what I want to do is kind of go through a problem that I see students make mistakes on time and time again. It's one of those problems that we a lot of times as teachers will present to students, to be able to do, but if it's not a problem that you actually practice on your own, you're bound to make mistakes. And it is definitely one of the most common problems that I see students that get wrong on tests and on quizzes or on their homework, because it's just one of those things that they don't practice. And a lot of times we I think as students, we get into our own kind of rhythm, like we, kind of understand how to follow like directions and, the process of a certain problem. And then we get to a problem like this where we think we're doing exactly what we need to be doing. And it's just a little bit of a change here that sometimes we don't pick up. So the main thing I want you to recognize here is that our denominators look very, very similar to each other, right? They both have x's and they both have 6's, but they are not created equal. Notice how this is x minus 6, and this is saying 6 minus x. Those are not the same expression. And if you don't believe me, let's go ahead and rewrite them and kind of see how this looks. Now, what I want to do is if I want to rewrite this expression to be like this, then what I simply need to do is swap my x and my 6. By doing that, notice here that there's a negative in front of that x. That is critically important. So whenever you're like rearranging your terms, right, you got to make sure you keep positive with positive and negative with negative. Like this is a positive 6. Now, a lot of times we don't write a positive symbol in front of that 6, but that's exactly what is represented there. That is a positive 6. So when I go ahead and rearrange my values here, I got to keep this negative with the x. So therefore, it's going to be a negative 6, or I'm sorry, negative x plus a 6. So notice here, a negative x plus 6 is not the same thing as an x minus 6, but they are very close to each other. And all we simply need to do now to get them to be equal to each other is I just need to factor out this negative, right? So remember, this is technically a negative 1, right? That you could say is being multiplied by the x. If I want my coefficient of my x to now be positive, I can simply just factor out the negative. So when I factor out this negative here, I'm now left with an x minus a 6. And if you're a little confused on this, just remember, you can always double check your work. When you're factoring out, right, you can always check your work by just multiplying back out your expression, right? When you factor something out, you're basically like dividing it out. So if you want to go back and check your work, just multiply back through. Negative 1 times x is negative x. Negative 1 times a negative 6 is going to be a positive 6. So you can see how it worked out. Ta-ding! So let's go and use this knowledge now to go ahead and rewrite this expression here. So therefore we don't make a mistake when we see a problem like this. Okay, so now you can see is I just rewrote this 6 minus x as a negative 1 times an x minus 6. Now, here's the cool thing. Whenever you have a negative in the denominator, you could rewrite this in front or up top. It really means the exact same thing. And if you're kind of confused on what I'm doing, like let me kind of explain it this way. If I had a negative 8 over 4, I think you would all agree that that is going to be equal to a negative 2, right? Just take 8 divided by 4, that's a 2, and then you have a negative out in front. Now again, this is the exact same thing. Let me put this right here though so you can see, right? So it's right in front there. Now that's the same thing though as a negative 8 over a 4, which is the same thing as an 8 over a negative 4, right? So it doesn't matter if the negative's in the denominator, negative's in the numerator, or negative's out in front. It all remains the exact same thing. So in reality here, we can actually bring this up in front here, right? I can actually take this and I can rewrite this as a 3, right? I can just rewrite this out in front. I don't need to keep it down in the denominator. And what happens here is now we have a minus a negative, right? And hopefully you all need like a minus a negative, that's gonna be double negative. That is now just gonna turn that into a positive. And now you can see we're simply just adding two rational expressions and they already have the same denominator, right? It was such an easy problem once you go ahead and fix this mistake that students make all the time on getting a problem like this wrong. So now I'm just adding these up. They already have a common denominator. So I'm just gonna do a 3 plus a 2, which is going to be a 5 over an x minus 6. Now, again, remember, whenever we are simplifying rational expressions, it is always very, very important to make sure we include our excluded values. Those are going to be the values that make your denominator equal to 0, because we don't want to do that. We don't want to divide by 0. So again, we want to look for what values makes my denominator 0. And in this example, you can see that 6 is going to be the value that makes my denominator 0. So I'm now going to exclude that from the domain of this expression. Now, this might be one of the most common types of problems that students get wrong, but in the next video, I'll go over one of the most common mistakes that students make when subtracting rational expressions.